So Avi Loeb just released some new info about 3-Eye Atlas today, as amateur astronomers are capturing the clearest images ever. And what we're seeing on November 16th and November 17th is once again raising some serious debates about the physics of this object. So in this video, I'll factually break down everything that's happening with 3-Eye Atlas right now. So 3-Eye Atlas disappeared behind the sun from our perspective back in late October, and for about 2 weeks we could not see it with ground-based telescopes at all. The Virtual Telescope project captured the first good images on November 6th. The comet was only 12 degrees above the horizon, which is really low, but even from that tough angle we could kind of see the ion tail forming. Then on November 9th we got even better images, and the tail became much more visible as the geometry improved. Now, when a comet moves around the sun, the angle we see the comet from changes. Before perihelion, the tail was kind of hidden behind the nucleus from our view. But now that the comet is moving into the morning sky, the tail is spreading out and becoming way more obvious. On November 11th, we captured images showing the ion tail stretching for about 1 million miles across the sky. The tail here is pointing northeast, which makes sense because that is away from the sun. But what's weird in the November 11th image is that you can also see a slight anti-tail pointing toward the sun. Then on November 15th, an astronomer in Thailand captured an even better image, which shows both the normal tail and this really prominent anti-tail at the same time. The anti-tail is super bright and well-defined. And then on November 16th, we captured what might be the best image yet. This shows the comet with multiple jet features and tails all clearly visible. The detail in this image is stunning. You can see the bright central coma. You can see the main tail sweeping away from the sun. And you can see those sunward pointing jets. Now, normal comets have tails that point away from the sun. This happens because of something called solar wind. The sun is constantly blasting out charged particles in all directions at over 800,000 miles per hour. This solar wind acts like a cosmic leaf blower, pushing all the gas and dust from a comet backward away from the sun. So when you see a comet, the tail always points away from the sun, no matter which direction the comet is traveling. But anti-tails like this are extremely rare. That means material points toward the sun instead of away. Now, we have seen anti-tails a few times before, but it has always been the case that the particles fall behind the comet as it moves, and from certain angles, this creates the illusion of a tail pointing sunward. But what we are seeing with 3-Eye Atlas is not an illusion. Multiple telescopes from different locations all see this anti-tail. It is a real structure. So the question becomes, what kind of material is creating it? And why is it not being blown away by the solar wind like it should be? Well, we have 3 different explanations for this anti-tail, and honestly, all 3 of them have serious problems. Explanation 1 is that the anti-tail is made of really massive dust particles. Let's check out the math needed for this explanation to work. The comet dust released from 3-Eye Atlas needs to have about 100 micrometer radius to fly through the power of the solar wind. Now, normal comet dust is about 1 micrometer in size. That is 1/1,000,000th of a meter. But a dust particle with 100 micrometer radius is actually 1,000,000 times more massive than a particle with a 1 micrometer radius, assuming they are made of the same stuff. So 3-Eye Atlas must be ejecting dust particles 1,000,000 times more massive than typical comet dust, because they are so heavy they would not get pushed away from the sun, and these heavy particles launch behind the comet, creating the anti-tail pointing toward the sun. But here is the massive problem with this explanation. To produce the brightness we are seeing in these images, you would need 100 times more mass loss than you would with normal-sized dust particles. So if 3-Eye Atlas is using giant dust particles, it would need to be ejecting an absolutely enormous amount of material. But we already saw it didn't change its size after perihelion, so the math doesn't really add up. Explanation 2 is that maybe instead of dust particles, the anti-tail is made of actual chunks of ice. When ice gets ejected from the comet, it starts sublimating immediately because it is exposed to direct sunlight. The ice fragments scatter sunlight just like dust does, but they usually evaporate before they have a chance to turn around and form a traditional tail pointing away from the sun. So, from our viewing angle, we see this bright structure pointing toward the sun that is actually just evaporating ice. This explanation has a problem too, though. For ice fragments to create the brightness we are seeing, they would need to be pretty big. And if they are big enough to scatter that much light, they probably would not evaporate fast enough. They would stick around long enough to eventually get pushed away by solar wind and radiation pressure. So this explanation kind of works, but it requires some very specific conditions. The ice fragments would need to be exactly the right size to scatter enough light, but also evaporate quickly enough. That's a pretty narrow window, so the chances are that this is not the case here, even though this is the theory I find most fitting. So let's talk about the third possible explanation, which I personally disagree with, but probably about 80% of people believe without a doubt. So we have seen objects in our solar system that looked like comets, but were actually technological. NASA's rocket boosters, SpaceX debris, all of these things can look like dark comets from a distance. If these jets are from thrusters instead of natural outgassing, they would be moving so fast that the solar wind could not deflect them. They would punch straight through the solar wind and create these tightly collimated beams pointing in whatever direction the thruster is aimed. This would completely explain why the jets point toward the sun. They would not be pushed by solar heating, but rather be aimed by a propulsion system. Technology has advanced so much that you can get a telescope for $500 that can see objects this far away. The Virtual Telescope Project is hosting live streams, soon capturing the comet in real time. The ion tail is growing. The antitail is still prominently visible. The coma is bright and well-defined. This object is putting on a show. The fact that it survived perihelion without breaking apart is actually pretty remarkable. A lot of comets fragment when they get close to the sun because the thermal stress is so intense, but 3I Atlas made it through intact. Images from November 11th clearly show one solid object, not fragments, not pieces spreading out, just one nucleus with jets and tails emanating from it. If the jets continue, even as the object gets farther from the sun, that would be really weird. Natural comets always get less active as they move away from the sun because they are getting less solar heating. If 3I Atlas stays active, that would suggest the energy source is not coming from the sun. Let me know down in the comments which explanation you find most believable. Also, drop me a like and click the hype button, and I wish you a blessed day.